All right, so use the leading term and give the end behavior of each polynomial. So you can tell that it is positive with an odd exponent. So the right end is going up while the left end goes in the opposite direction. So one goes to infinity, the other goes to a negative infinity. Here, negative with an even exponent. So I start with the negative in front. That means it's going down to the right. The even exponent means the other end is going to join it. So negative, that means the right end is going to negative infinity. Odd exponent means the other end is going to go the opposite direction. Positive, I don't care, it's a fraction. Positive fraction means the right end is going up. The left end, because with an odd exponent, goes in the opposite direction. Again, the leading term here is positive, so the right end is going up, while the left end has an even exponent, so it joins it. So both ends are going to infinity. Here's the last one. Negative in front, that means the right end is going to negative infinity. Even exponent means the left end is going to join it. What can you tell me about the graph and what the power term must be? So what's happening to both ends? They both go in the same direction. So it must be even. So there must be an even degree, if I can do that. And because they're both going down, it must be a negative coefficient. Let's try that again. Look at the ends. So I see they go in opposite directions. That means there must be an odd degree. And because the right end is going up, there must be a positive coefficient. So again, I look at both ends. They go in the same direction. That means it's even. Then I look at the right end. In this case, you can look at both. They both go up, so that means there must be a positive coefficient. 10. Type this into Desmos. Can you classify it? It's a cubic. The domain and the range will be all reals because it's an odd polynomial. On Desmos, can you find the bottom and top turning points? So we have a turning point, a bottom one at negative 2, 1, and a top one at negative 4, 5. I'm going to put those on my graph. I like putting down well, I can't put down the y-intercept. So those are the 2 points I'm going to use to graph this. You could find the intercepts using Desmos to be a little more accurate, but what I do care about is that it's curved and that we see these two and understand what direction the ends go as you connect with the turning points. So it's increasing from negative infinity to negative 2. It's also increasing from, or not negative 2, negative 4. And then from negative 2 to infinity, it's increasing. So it increases to here, and then increases again. There's one piece in the middle there where it's decreasing, using the x-coordinates of the turning points. So from negative 4 to negative 2, it is decreasing. And what's the end behavior? We said this already. Right end is going to infinity, while the left end is approaching negative infinity. Turn the page. Again, type this into Desmos and feel comfortable understanding the turning points, the intercepts that can help you graph this. So the power term is to the fourth. So we can call that a quartic. The domain is all reals, but the range is going to either have a bottom or a top point. Where are the minimums for this? So we have a minimum if we approximate it at negative 0.9 and negative 3. We also have a maximum at negative 2.5 and about 2.5 or so. We also have another maximum at 0.3 and negative 0.3. So we'll approximate those right now. So negative 0.9 and negative 3, negative 2.5 and 2.5, and then 0.3 and negative 0.3. So it's like, oh, right there, almost at the origin. And what do I care about is the end behavior. So where's the right and the left end going? So how do I know? Negative means it's going down. The even exponent means the other end is going to join it. So I know this end and this end are going down, and then I connect the others with a smooth curve. So it's increasing from negative infinity to this point. What's the x value of that turning point? That's negative 2.5. It's also increasing from this turning point. So what's the x value there? Negative 0.9 to that turning point, which is 0.3. Now where's it decreasing? So it decreases from this turning point. So that's negative 2.5 to this turning point, which was negative 0.9. And from this turning point, which is 0.3, all the way to infinity. So take the x coordinates of the turning points, and that tells you where it's increasing and decreasing. All right, two more. 12 and 13. Use Desmos, press pause, then come back. You, then me. So this is called a quartic because the exponent is 4. The domain is all reals. Oh, you know what? I didn't go back to the range. So we actually have a top value here. I need to know the y value of that top value, which is about 2.5. So it goes from negative infinity to about 2.5. Remember, bottom to top. All right, so this range, again, we have an even exponent, so I got to wait. So type it into Desmos. What are the low turning points? So we have a low turning point at negative 1.4 and negative 5.2, and we have no maximums. So negative 1.4 and negative 5-ish. So what do I know about the end behavior now that I have one turning point? I also know that there's a y-intercept at positive 1, so that's kind of nice to at least know that I can curve through something. So both ends are going up. And I know there's a bit of a hitch here as it goes up. So it kind of looks like that on Desmos. But when it's increasing, I use the turning point, negative 1.4, and it goes to infinity. That's where it's increasing. It decreases from negative infinity to negative 1.4. That's it. Last one. Type it into Desmos, classify it, graph it, analyze it. So the degree of this is 5, so we call it a quintic. The domain is all reals. And because we have an odd exponent for the degree, the range is also all reals. Now, on Desmos, approximately, we have a minimum at about negative 1.5 and negative 1. We have another one at about 0.4 and 1.5. We have a top turning point at negative 0.4 and 2.5-ish, and 1.5 and about 5. For another turning point. So if you click onto Desmos, use the plus or minus sign to zoom in or zoom out what you need, and then click on those gray points. You then just round the answers that you see. So I'm going to put those in my graph. So negative 1.5 and negative 1, 0.4 and 1.5, negative 0.4 and 2.5, and then 1.5 and 5. So those are my turning points. I want to know the end behavior. So I see, left end, that we have a negative in front of the power term. So that means the right end's going down. The left end then has to go in the opposite direction because of the odd exponent. So I know the right end is going down, and I know the left end is going up. And then just connect the points that we have, smooth and continuous. I know that 2, we have a y-intercept. That's that constant at the end when you plug in 0 for x. So connect. There's your curve. So where is it increasing and decreasing? So at about negative 1.5, this turning point here to the next turning point, it's increasing. It's negative 0.4. This one. And then where else is it increasing? This turning point, the next one, which is at 0.4 to the next turning point, which is 1.5. So there's two little areas of increasing, and then everything else is decreasing. So negative infinity to negative 1.5, negative 0.4 to this one, which is 0.4. And then the last bit, the turning point, the x-coordinate, so like 1.5 all the way to infinity, the last part is decreasing. So most of this is decreasing with little bits of increasing. All right, what a great practice introduction to polynomials. I appreciate you that you practice what we did in class, and it's going to pay off. All right, Mr. G Math, over and out.